And we're live.
Okay.
So,
do you want me to start my presentation?
Sure, let's do that.
If I can actually find it. It's underneath a few layers of windows here. Screen share. This is a little different format than the regular Hangouts. Okay.
Yeah, it's because it's a Hangouts interface through YouTube.
Okay, gotcha. All right, so you can see my presentation. It's present, and now it's nice and big.
Yeah.
Okay. So look, this is on collections. I'm just going to go through the ones that we had to know for the class. The list, set, tree, which is really just another version of a set, from what I understand. Map and queue. So, so collection is the root of the collection hierarchy. So I'm just reading off my notes here. A collection represents a group of objects known as its elements. So the collection interface is the most common denominator that all collections implement and is used to pass collections around and manipulate them. Some are ordered and some are unordered. So the list interface, the elements can be inserted or accessed by their position in the list using a zero-based index. A list can contain duplicate elements in addition to the methods defined by collection. List had defined some of its own. So if you remember back to 260, we used an array list, and that was one of the type of lists. There's a linked list also, and I believe there's another one. And I have some code examples I'll show when I get done running through these different slides. If you guys have a question along the way or want to throw out a comment, go ahead. I don't know if I'll be able to answer it. Maybe we can answer it together. All right. So the set interface, this interface extends the collection to handle sets, and they need to contain unique elements. It's a collection that cannot contain duplicates, so you can't have the same thing in there twice. And it's kind of like a mathematical set. It contains only methods inherited from collection and adds the restriction that duplicate elements are prohibited. And it also adds a stronger contract on the behavior of the equals and hash code operations. So it allows the set instances to be compared meaningfully, even if their implementation types differ. So the most important thing about set to remember is they can't contain a duplicated item. And a tree set is it's a class of the set interface. So tree set provides an implementation of the set interface that uses a tree for storage. Objects are stored in a sorted and ascending order, and access and retrieval times are quite fast, which makes tree set an excellent choice when storing large amounts of sorted information that must be found quickly. The map interface maps unique keys to its values. A key is an object that you use to retrieve a value at a later time. Given a key and a value, you can store the value in the map object. After the value is stored, you can retrieve it by using its key. It cannot contain duplicated keys, and each key can map to at most one value. And then Q, the one that for some reason was a bit of confusion, but it's really just a first in and first out data structure mostly. So new elements in a queue data structure are added at the back and removed from the front. The process of adding an element at the back of the queue is called enqueue, and the process of removing an element from the front of the queue is called dequeue. And Java uses a queue interface, which is part of the Java collections framework. Queues can be used to hold multiple elements prior to processing. And besides basic collection operations, a queue provides additional insertion, extraction, and inspection operations. They typically, but they are not necessarily order elements in a first in and first out order. The exceptions are priority queues, which order elements according to a supplied comparator of the element's natural ordering. Whatever the ordering used, the head of the queue is the element that would be reviewed by a call to remove or pull. All right, so that's the slides. And then to make sure NetBeans is showing up. You guys?
No, I'm still seeing your slides.
Oh, okay. Yep. Well, I have to switch it in the other thing if I can find the Hangout. There we go. There we go. All right. Now NetBeans is showing up?
Yeah.
Okay, perfect. Okay, so I just put a quick example of each one on the same, in the same program. So I'll just kind of look at it real quick. So this is an example of an array list or the list type collection. I use some familiar names here. Create the array list. We just added a few Star Wars characters to it, and then we go ahead and print out that basic array list. A set. This is just a set example. So when you do this, these are basically going to come out in the order that they were put in, I believe. They're not going to alphabetize. When you do a set, they're going to put themselves in numerical order, so it'll work itself out. Remember, you can't have a duplicated one in here. A map example, I just used to value. I used a string for the value and a string for the key. And this is just Led Zeppelin. The tree set is very similar to the set, but instead of numbers, I used colors, and this will alphabetize, I believe. And then the queue is however you put it in, it's going to come out. So go ahead and run that. So this one comes out in the way that it was set up. The set puts it in order for you. But the map, it is random output. It's no, from what the tutorials I went through, there's not any kind of order. It's not alphabetical. It's nothing like that. It's just comes out in the order that it decides to put it out. The tree set basically alphabetized it, and the queue is the same order that it was first in and first out. So that's collections.
Cool. I think that's pretty straightforward.
Yeah. Good stuff.
Cool. Any questions, comments, anything to add?
Just with the tree set element, can't you add multiple like branches to each item too? Like each item can have items, or am I thinking of something else?
Maybe. I don't know.
Okay. Well, I haven't dealt with it a lot. I've dealt a lot with nodes and stuff, so
I'm pretty sure that's how C++ trees operate, so I'm not sure. I don't know why Java ones wouldn't be.
Yeah.
Able to do that.
All right. So I don't know what's actually showing to you on my screen right now, but I'm trying to unshare it. There it is. All right.
Black screen. Cool. My turn then?
Yes, sir.
All right. Let's focus on me. To everyone. Share screen. Okay. So I did some research on threads, runnables, and executors, and it turns out that they're basically just like three aspects of like code execution. So threads are like the thing that's actually doing stuff. They're basically like processes in the background on your Windows Task Manager. It's like a thing which is doing something. Multiple can be running simultaneously. The number depends on the processor of the thing. Depends on the number of threads that's given, and like you can max out a CPU if you give it too much of a load. And it's first in, first out kind of situation there. Runnables. It's basically a Java interface that makes a class able to be executed, quote unquote. It must implement the run method to be able to do that, and that's pretty much it. It's fairly straightforward. And executors are the thing that create threads, execute runnables. It's kind of like the task manager itself. It has a sub-interface called executor service that is far more useful than the executor interface itself, in that it has a bunch of like automation tools. There's also a scheduled executor service scheduled, which has even more like scheduling methods which it can use for task maintenance, that sort of thing. All right, live demo time. Here is my thread executor runnable class in NetBeans. Do I need to increase the font size?
Yeah, a little bit.
Yeah,
I'm watching on my phone, so I'm like squinting already.
Okay, I will do that. I looked at the broadcaster and it was like super tiny, so we're gonna go to 24. Is that better?
Yeah. Yep, that's good. Thanks.
All right. So here we have the class name, which is relatively irrelevant. The most important part is that it implements runnable, which makes the class itself able to be executed. And this is just a little thing that I made that isn't particularly pertinent. Default constructor with a string parameter, and now the good stuff. So here we have that run method I mentioned earlier. And basically when this class is run, this is what is executed. And I have here a method which outputs the command that it was given, a method which processes that command, and a statement that shows when the end has occurred. And so this is the command itself. Basically, we're telling the thread to just like chill for 5 seconds, and then to that's basically it, is just sleep for 5 seconds. And then this is a explanation which will output the threads as they are running, the tasks. And yeah, let's see what it looks like. So over here, I'm not sure how to make this bigger. There we go. So this is the main menu of my program. On option 2, demonstration. Okay, so basically what happens is the executor service creates a pool of threads. And in the loop, during that process, right here, a total of 10 threads were created. But the pool only has 5. So basically, in the first round, thread 1 through 5 executed the command 0 through 4. And then in round 2, as soon as all of those were done, it's the same thread pool. So this and this refer to the same thing. Execute the commands again. Basically, yeah. So it's the same thread executing new commands. And then when it's all done, it just dies. So yeah, that's threads, executors, and runnables. Any questions, comments, concerns? High-pitched uvulations.
So I have 2 questions. One,
cool.
How would we apply this to what we're doing?
It depends. Like, if you have, for instance, if you're using an API for some reason, if you're referencing an outside source, connecting to it could be something that is accomplished by a thread, which is governed by an executor. I don't think we're going to be dealing with that particularly in this class. Like, I'm pretty sure the scope of this particular concept is supposed to be know how to use it. I don't know if we need to do stuff with it.
Yeah, it's hard to know how to implement it, but another example that I've run into before is sometimes you'll need information from a website for whatever program you're using, and usually your the library you're using to grab information kind of implements it itself. But if you're creating your own kind of library, you'll need to pause a thread while pause everything while you're waiting for information to get from the website so you can generate things. Or, yeah, there are other implementations for it. It's a lot of times people, if they really know what they're doing to really optimize how fast something runs, they can manage manually each thread when each thread does what it does.
Yeah. I think we will use this a lot more when it comes to QC-JSON and JSON and servlets specifically.
So really, this is when you create a thread, it's running a different thread besides the main program, and if it's going to take longer for something to be accessed, you can have 2 different. You can have that thread running without pausing your main thread. Is kind of what I was getting.
Yeah, you can, yeah.
Okay, that makes more sense. My other question is, and I'm pretty sure it was this one, but was there something mentioned about an atomic variable in this particular piece on the sheet or in his notes?
I do not know.
It's my first time hearing about something like that. Since how much I pay attention.
Well, he put that little PowerPoint together and all those little videos, and I think for what we turn in for this, to know basic, we're supposed to do something with what's called an atomic variable. I have no idea what that means, but I could read it. Just pull it up real quick, figure out where I stashed that.
It's part of the concurrent package, which is the package that contains executor service and executors.
Okay. So
it supports atomic operations on single variables. Classes have get and set methods that writes on volatile.
So you kind of covered that with the executor, by the sounds of it, kind of. Sorry, I'm not trying to be difficult. I'm just trying to understand.
Oh no, you're good. This is something that I need to understand as well. So atomic is a kind of variable, as is volatile and synchronized. So I assume that if you're trying to have, if you're trying to get thread execution with, one with like, brain mouth, like I'm trying to mouth how my brain is braining at the moment, and it's not mouthing. So I know synchronized threads, basically they'll all just like stay active until it's like that whole pool it's like a chunk that operates on something, whereas atomic, I assume, is just kind of like goes and does its own thing. Or maybe that's volatile. I don't know. I'll have to do more research on this topic.
I'm gonna read what this is under threading on that little PowerPoint. It says tips to get to basic. I want to see a program. You'll have to have more than one class in this that uses a combination of threads, executors, and runnables together. Also think about how you would manage an atomic variable where multiple threads read from and write to the variable. So that's knowing basic on that one. So yeah, because I've run across quite a bit of information on threads and runnables, and not a whole lot on executors.
It makes it sound like it's talking about it like it's some kind of a global variable, where regardless of what thread is accessing it, it's always, either changing its value or it's like a static field, is kind of what I'm getting, but with multiple threads accessing it from different areas. I don't know. That's what I understand from it anyway.
Yeah, that kind of makes sense.
But anyway.
Yeah, there is a lot there. I have found a couple of links that I will pass along for that.
Cool.
Oh, it's multi-threading. That's basically what it is allowing multiple threads to work on one thing.
Oh, okay.
Basically, it guarantees the reading and writing a variable. Declare the weird. There's a lot of stuff on that. I will research that and come back to you.
Thanks.
Cool. Any more questions?
I'm good here.
Cool. How's everybody doing with this class?
So far, so good. I'm looking forward to learning some few extra things. There are quite a few things that I'm already familiar with, so that kind of gives me a leg up. But the threading thing, definitely, I haven't worked with that at all, so that'll be interesting.
Yeah, I'm kind of all over the place, so I kind of settled myself down to try to just grasp two things at once instead of trying to jump all over the place. So
yeah,
that was because I'll be working on something and then somebody will post something about something on the discussion board. I'm like, oh, let me check that out. And suddenly I'm going from collections to serverlets, and then I'm jumping to JSON, then I'm jumping to Hibernate, then I'm jumping back to collections, and I'm like running in circles. I'm like, I'm going to quit reading the discussion board.
Well, you'd be surprised at how closely all of these aspects actually work together in a web app.
Well, that's true too.
Yeah, all of these work together. It's really insane how rounded an application can become when you use all of these things in it.
Yep.
All pieces of the whole. Well, I'm glad you're in our group, Eric. You can give us some good knowledge.
Yeah, I'm mostly familiar with like servlets and Tomcat and and working with those things. So, and with the MVC thing, I'm really familiar with that too. So,
yeah, then that's it, it's the one thing. I looked at MVC and I'm like, wait, what is that again? It turns out, oh, it's the model view control pattern, which is, as you can see, I have implemented here. So
yeah,
it's
right.
like,
Well,
how much more is required for that? Like
336 definitely will embed that into your mind.
Yep.
Cool. I don't really know.
yeah.
Is there anything else we need to cover? Or
Yeah.
is there anything anybody needs help on? Should we collaborate on like something that someone's struggling with, like a concept? I don't know.
So
Like,
for what you're going to turn in, are you going to turn in for your report, your familiarity? Wow, I can't even say it.
Familiarity review.
Yeah, thank you for saying that for me. It was stuck in my mouth. I think your little stuck in mouth disease is spreading across the internet.
Yeah, it's contagious.
Is this what you would turn in for that? Or are you going to make it bigger? Or
I'll probably do something with an atomic variable in here instead of just like a dumb little, hey, here's a thread and it's sleep.
yeah.
I'll probably try and do something there.
Yeah, you don't have to do everything in one program. You can, like, along the way. I've done this sort of thing before with this kind of structure, but with like HTML and JavaScript and all that stuff, and basically you just turn in little projects here and there for the first 10 weeks to kind of prove that you know the concepts, all of the concepts that are listed, and then from like week 10 to 14, you kind of develop a well-rounded application using all of these aspects. So
yeah, the way I've been doing it thus far is that I've basically just mushed all of the little things into one, where it's like I just have these dumb little demos that run, and then I figure for the bigger application I'll just add another class and have it do something neat. Like, that's my list demonstration. It's just like, it's like, oh, here's what it does. That's cool. And there's like menu navigation and stuff. I probably spent too much time on this in retrospect.
it looks nice. It's readable.
Yeah, it's really nice.
That was the goal. If anybody wants, I'm like weirdly proud of this banner class. Basically, instead of using system out, pretty much all of my output is through banner. And I have like a big banner and a small banner.
I've never used Banner before. I'll have to remember that.
No, this is something I made.
Oh, you made that class. That's right.
Yeah.
You made it sound like that you like grabbed Banner from some library or something.
Yeah.
It is the library of me.
Well, good job on that.
Yeah, very cool.
Yeah. I'm pretty excited about it. Again, too much time. I probably should have spent more time on learning about atomic variables or something, but
They're not as visually appealing as what you created, though. So.
All right. Well, I'm going to take off. Thanks for the presentation.
All right. Thank you,
Excellent.
Eric. Thank you, everyone.
Yep. Same time next week, everybody.
Yep. Who's teaching next week?
Let's.
I think I have and I think I'm doing MVC next week.
Neat.
Cool. All right. I'll see y'all later.
All right.
All right. We'll see everyone.
See ya.
Yep, bye.